Okay, so let's look at the last 6 of these problems. Here, in all of these equations, it's not solved for 0 yet, okay? So the idea is that I need to move everything over to the left-hand side. So on 17, I have 21 on the right-hand side. So to get rid of that, I'm going to subtract 21. Okay, and then I also need to subtract 21 from the left-hand side, right? Whatever you do to one side, you have to do to the other. But if you notice, I don't have any constant terms on the left-hand side. I have an x squared and I have a positive 4x. I can't combine 21 with any of those, okay? So I'm still going to subtract 21 from both sides, okay? But what it's going to be is that it's going to be x squared plus 4x minus 21. Okay, and then now that equals 21 minus 21 is 0. Okay, so whenever you're solving, whenever you are, trying to eliminate terms on a side, okay, if you don't have anything to combine it with on the other side, that's okay. You still just write that minus whatever it is. So here in our case, minus 21. Okay, so now it's ready to be factored. So it's a trinomial. So I know my trinomials can factor into 2 binomials, okay, if they can factor. And so the leading coefficient is 1. So I'll start with an x on both sides. And then I need 2 numbers that multiply together to give me negative 21 and add together to give me a positive 4. I think I'm going to have a positive 7 and a negative 3. Okay, I think that'll work out. Okay, so then I set each piece equal to 0, create these brand new equations, okay? And then so the first equation, you get x equals negative 7. And then my second equation, x equals a positive 3, right? Because you add 3 to both sides. Okay, so here on 18, I have x squared minus 45 equals 4x, okay? I need to move that 4x over to the other side. And so I'm going to subtract 4x from both sides, okay? But there's no other x's on the left-hand side to take 4x's away, right? But I still need to subtract them. So, if you want to write that you're subtracting the 4x, go for it. We're not going to say, we're not going to combine it with that constant. So what do we have left on the left-hand side? I have x squared. Now, I want to write this trinomial in standard form because it helps me factor, okay? It helps me factor when I have the x squared term first, and then the x term, and then the constant. So I see that I have a minus 4x, so that's what I'm going to write next, minus 4x, okay? And then now I can do the minus 45. Oops. Didn't mean to change my color there. Okay, minus 45. Okay, and then now on the other side, 4x minus 4x equals 0. Okay, so I'm moving that 4x over there by subtracting 4x's from both sides. And then in the same step, I decide to make sure that I am writing my trinomial in what we call a standard form, where the x squared goes first, and then the x term, and then the constant. Okay, so it's a trinomial, so it's going to factor into 2 binomials. Its leading coefficient is 1, so I got to use the shortcut method. 2 numbers that multiply together to give me negative 45, add together to give me negative 4. I think a negative 9 and a positive 5. Set each piece equal to 0. Okay, and so here we have x equals a positive 9 and x equals a negative 5. Okay. All right, number 19, right? We need to get the 7x to the other side, so I subtract 7x from both sides. But if you notice this time, now I do have x terms. There's a negative 5x on that side, so I get to combine those 2 terms together, okay? So always kind of know whenever you're moving those terms over, is there something else that you can combine it with to kind of simplify that side? So what am I going to have left? I have x squared. Okay, now I'm going to take negative 5 minus 7. 7 gives me a negative 12x's. Minus 64 equals 7x minus 7x is 0. Okay. All right. Now, whenever you factor, Got an X on both sides, right, or to start off my factoring. And then, so I need two numbers that multiply together to give me negative 64, add together to give me negative 12. I think a negative, let's see. I know that 8 times 8 is 64, but that wouldn't give that to me. Maybe 16 and 4, negative 16 and positive 4. Okay, I think that works out. So set each piece equal to 0. And then x plus 4 equals 0. So you have x equals a positive 16 or x equals a negative 4. So either one of these values satisfies my quadratic equation. Okay, I am going to leave number 20 for you guys. Okay, you'll have to subtract the 4x, right? Subtract the 4x. And then you'll also have to subtract the 1. So those will go away and equal 0. And you'll just combine those like terms. So x squared minus 14x plus 48. Okay, so I'll let you guys factor that and solve it. Number 21, I'm going to kind of show you how to set it up and then I'll let you factor. I'll have to subtract x squared from both sides. This is 11x squared is an x squared term, so I can subtract it from there. I also need to subtract 8x from both sides, but there's nothing to combine it with on this side, so you'll still have minus 8x. If you want to kind of write it in there. 11x squared minus x squared is 10x squared minus 8x, right? We're going to still subtract them. And then all of these go away, so it's equal to 0, okay? There's a greatest common factor that you can factor out of those two terms. Okay, here, subtract 9 from both sides. 16x squared minus 9 equals 0. Okay, what method are we going to use? We're going to use the difference of squares to factor. Okay, so finish the problems 20, 21, and 22. I kind of got them started for you. Now it's just your turn to factor and then set them equal to 0, solve those linear equations, and you have your solutions.